Lesson 3, Systems of Inequalities. Systems, you're going to have two lines here. You'll graph two lines. When you graph both of them, they'll intersect and they'll create four zones. Think of it like this. If you have this area, you have zone 1, 2, 3, and 4. So you're gonna only shade one zone. Yesterday, when you constructed your graph, you had two zones that you had to worry about. Today, you'll have 4. So we'll go ahead and first off start by graphing these two that are already in slope-intercept form. We'll simply call this one equation 1 and equation 2. Our slope here is -1/2. Your intercept is 2. Plot your intercept. Use your slope. Your slope is negative, so that line should decrease. So up 1 over 2 in a decreasing fashion. Up 1 over 2. We'll use it a few times here to get a few plots. We look at our inequality sign. Our inequality sign is greater than or equal to. Greater than or equal to, we'll have a solid line. Now we'll go ahead and take care of our shading. Right now we only have two zones. So lightly shade the zone that needs to be shaded. So that's in slope-intercept form. It is greater than or equal to. So I would lightly shade in this top side. Okay, these are all possible solutions for that inequality. However, we have a second inequality. That second inequality, we have x is less than or equal to 2. Remember, this is telling you that it crosses the x-axis at 2. So here's where the x-axis is 2. I look at my inequality sign. The inequality sign is less than or equal to. So again, this would be a solid line for my graph. Secondly, I see that it is less than or equal to. Less than or equal to means I would shade the bottom half or below the line. So here's my shading below the line. It would be all this side. And where the red and green come together, that's where you darken it in. This here is your solution when the red and green come together. So really, all this other red and green that we have filled in here, you could erase, but if you lightly shade, it's not a big deal. So that section there is the solutions that would work for both inequalities. Example 2, already in slope-intercept form for us. So again, I'll pull out my slope and my intercept. I'll start off by graphing equation 1. Our intercept is 2. And our slope is 3, or 3 over 1, so up 3 over 1, and this would increase up 3 over 1, or I could go down 3 over 1. And I have a bunch of plots here, so now I look at my inequality sign. That is a less than sign. Less than sign means I would have a dotted line. Remember, all the values there are not included for that dotted line. Next, I need to go ahead and shade. That is a less than sign. Less than sign means I would shade below the line. And remember, you're lightly going to shade. So this would be the lightly shaded area for that inequality. Next, go ahead and graph the second one that's in slope-intercept form. And we have b is -3. So I'll plot my intercept first. And then my slope is -2 over 1. So this line should decrease. So I'll go up 2 over 1, up 2 over 1, and make sure it's decreasing. I'll use my slope a couple times to get a few plots here. I look at my inequality sign. That is a less than or equal to. That means that is a solid line. Now that I have that boundary line graphed, I need to go ahead and figure out my shading. My shading is less than or equal to. A less than would be below the line. So again, I'll shade below the line. And when I start shading below the line, you can see where the red and the green come together here. The red and the green come together, darken it in. That is your solution for these two inequalities. Those solutions will work for both graphs. When you have it lightly shaded, you don't really need to erase it, but I'll just show you that this is actually all you need is the shading right there. So that would be our solution in example 2. Problems here in example 3. Example 3, we need to get both equations here in slope-intercept form. So I'll take equation 1 here. That is 2x minus y is less than -1. I'm going to go ahead and put that into slope-intercept form. I would do that by subtracting 2x from both sides. I would get negative y is less than negative 2x minus 1. Need to get y alone. In order to do that, I would divide by negative 1. When you divide by a negative or multiply by a negative, your inequality sign flips. So I'll flip the sign. And now I have y is greater than negative 2 divided by negative 1 is a positive 2x. Negative 1 divided by negative 1 is a positive 1. So in this, my slope here is 2. My intercept is 1 for equation 1. Same process for equation 2. Equation 2, you have 2x plus y is greater than negative 3. Get rid of 2x, so I'd subtract 2x from both sides. I have y is greater than negative 2x minus 3. From this equation here, we find out that the slope here is negative 2, and your intercept here is negative 3. So we'll go ahead and graph these here. Equation 1, my intercept being 1, I'll plot that. My slope is 2, or 2 over 1. So that is positive. It should increase, so up 2 over 1. Use my slope a few times to get a few points on my graph. Next, I need to go ahead and check out my boundary line. That boundary line is a greater than symbol, so this is a dotted line. So I'll come up and draw a sketch of dotted line here. There's your dotted line. This would be equation 1. Next, determine the shading. Well, that's again revolves around your inequality sign that is greater than. Greater meaning above. So I'll shade above the line. Lightly shade. Equation 2, we have our intercept is negative 3, so I'll plot negative 3 for my y-intercept. My slope is negative 2 over 1, so this line will decrease. So I'm going to go up 2 over 1, make sure the line decreases. Put my slope on here for a couple times so I have a nice line that I can sketch. I look at the inequality sign. The inequality sign is a greater than symbol, which means that this also has a dotted line. So I'll construct my dotted line on my graph. All these values on that line are not possibilities or not solutions. And this is equation 2. Look at your inequality sign. Greater than again means above the line, so you start to lightly shade here. When you lightly shade, you figure out where the red and the green come together, and this is the section that needs to be darkened in. So you fill it in nice and dark to prove that these are the possible solutions for these graphs. Example 4, why don't you give this a shot on your own? Notice that both equations are not in slope-intercept form, so we need to get them into slope-intercept form. So why don't you go ahead, work through this problem, get them both in slope-intercept form, and then check back in, and then we'll graph them. Here's equation 1 in slope-intercept form. That's the process that you should have taken. Hopefully you have it looking like mine here. If not, double check your work. Here's what equation 2 should look like in slope-intercept form. Notice y is now greater than or equal to. Why is that? Because we divided by a negative 2, so we had to flip our sign. So hopefully you have that. Now we're going to go ahead and graph these two. So why don't you go ahead and graph equation 1 and graph equation 2 and then check back in. There's equation 1 graphed, shading above the line being greater than. Now we'll go ahead and add the second graph on here. There's equation 2 graphed. We look at our inequality sign. We need to shade above the line, so we start shading above the line, and we determine where that red and green come together. And that red and green come together in that those are solutions. So that's the area that we need to darken in, because these are the solutions for our inequalities here. This will conclude lesson 3, systems of inequalities.